Thank you, Caspar. The floor is yours.
Cool. So, so this is a paper. This is the final paper from my DPhil, and what it is about trying to see whether well-being reports are comparable over time. And it sort of connects to the workshop that we had at the center a couple of weeks ago. I also presented the paper 2 weeks ago, I think, at the LSE, and I see that Richard and Katja in particular are here, and I hope I will address some of the concerns they had 2 weeks ago with a little bit more intuition and an additional slide that was specifically made for Richard, who kindly reached out to me afterwards. So yeah, but in general, what's the motivation here? So as we all know, there's quite a large literature on the determinants of subjective well-being, and that literature, as we all know, uses responses to questions like, how dissatisfied or satisfied are you with your life overall? And then answers are recorded on this numerical scale. Here, for example, so that's the BHBS question, from 1 being not at all satisfied to 7 being completely satisfied. Now, what we want to do is, based on these reports about well-being, we wish to make some inference about the effects of covariates on actual well-being, where, covariates can be anything from gender, ethnicity, or income, the sort of thing we're all interested in. But the problem is that we don't actually observe actual well-being. So, and this is, I think, a fairly general hurdle. So that isn't just one that people working on subjective well-being are facing, but pretty much any sort of data that relates to subjective items. So that might be social trust, that might be political preferences, that might be measures of optimism, or that might be more generally clinical measures that are more often used by psychology. And for all of these, I think this problem of moving from reports to an underlying quantity exists. So in an ideal world, we would want to run a regression where the actual well-being level here given by SIT, so satisfaction for respondent I at time t, is just made a function of a set of explanatory variables, here just x. But the problem is that SIT is unobserved, and all we do see is RIT, where RIT are the actual responses. And typically in the literature, we think that these responses are sort of generated by a rule, where a respondent responds with category K if and only if that respondent crossed some thresholds but didn't yet cross some other thresholds. And in particular, that this respondent crossed the K-1th threshold but didn't yet cross the Kth threshold. So that's illustrated here, where you've crossed the threshold for saying a 3, but you didn't yet cross the threshold for saying a 4. Now, Richard, 2 weeks ago...
Can I make the same point I made before? I mean...
I was going to make your point.
Okay.
But do make it then.
No, just
try to respond.
If you want to appeal to the reader, this is not how a reader would answer the question. They would give the score which was nearest to what they thought the true score was. So surely you can reformulate it and do exactly what you do, but with that more realistic approach.
Yeah, so the idea would be, I suppose, that imagine that here in the middle between this tau 1 and this tau 2, where sort of in the mind of the respondent, where the number 2. And sort of here somewhere below tau 1 would be in the mind of the respondent, the number 1, and so on. And then a respondent would, think, okay, so long as I'm below this level tau 1, I'm closest to the 1 in my mind, and so I will respond 1. And then, as soon as I crossed this tau 1, which will lie somewhere in the middle between the 1 in the mind of the respondent and the 2 in the mind of the respondent, that respondent would suddenly switch over to the 2. So in that sense, the respondent would round her responses up or down. But that's perfectly equivalent to the idea of these thresholds. I just didn't mark in here the numbers.
That's
but
right.
I think it's a similar thought. I find it more natural, but maybe that's an issue with myself, to think of crossing some thresholds when I think about which number to give.
No, that's perfectly right. But the thresholds are in between
Sure.
the numbers rather than at the numbers.
If indeed you have numbers in your head and sort
And
of
then it's like
natural
1.5,
quantities.
1.5,
Yeah.
2.5, 3.5.
Yeah. So I think let's debate this a little further in the discussion, whether, because I don't have this intuition that I actually do have some number in my head that I try to round up or down, but it would be interesting to see how others feel about that. But just to move on from there, so apart from this rule here, okay, I need to have crossed some thresholds. I didn't yet cross these other thresholds. We impose two further assumptions. And the first assumption is that essentially these thresholds, that they are common across all respondents. So I captured this here by essentially just dropping the I and the T subscripts. And another assumption that we typically adopt when we use OLS regressions is to say that the differences between these thresholds are always the same. And so that's very natural in the way Richard thinks about it, because if there are just these numbers in the minds of the respondents, then of course these numbers are equally spaced, right? The number 8 is as far away from the 9 as the 9 is away from the 10. So, but what happens if this assumption of common scale use, which I'm concerned with here, doesn't hold? So then what I say is that scale shifts occur. And this can be illustrated with this picture here. So in the picture above, we see a person that has these thresholds sort of shifted to the right. And so for a given level of satisfaction, that person responds with a 3. But another person that has her thresholds shifted to the left, so that it's more stringent, kind of harsher in the way she uses her scale, that person responds with or is less harsh in the way she responds with her scale. That person responds with a 5. So same level of latent satisfaction, different response. And so it would seem to us that this person is in fact more satisfied than that person. So why might this sort of thing occur? Why wouldn't we believe that people all use the scale in the same way? So one argument that I found really compelling can be found in the book by Fleury and Blanchett. And the argument that they essentially make is that when people try to respond to these life satisfaction scales, they essentially think of a distribution of possible lives where they can find themselves in. And then they just choose with their response option, the quantile in the distribution of all these possible lives that they find themselves in, right? But the problem with that approach is that if the mean of that distribution is shifted, so the set of all possible lives that I think about when trying to answer the life satisfaction question, that they are suddenly all more valuable, then all these thresholds will shift too, without necessarily my own satisfaction changing. And so if that mean of that distribution depends on the same explanatory variables as the variables we're substantively interested in, then scale shifts of the sort that I'm worried about here will occur. A much more mundane reason, but that might be common too, are these ceiling and floor effects. So when I'm relatively close to the top end or the bottom end of the scale, then I will have some need to adjust my scale upwards or downward in order to still be able to communicate changes in my level of life satisfaction. So concretely, imagine I'm already at a 10, and then I become more satisfied, and I keep becoming more satisfied. At some point, I would just change the way I use the scale in order to start being able to communicate about that. Okay, in order to capture these scale shifts, what we might want to do is instead is to make these thresholds that I talked about dependent on a set of explanatory variables. And here I chose the exact same explanatory variables as the ones I showed when saying, okay, what does life satisfaction depend on? And the point is that scale shifts occur exactly when these deltas here are 0, right? When they are 0, then common scale use is just back on the table. So now we assumed 3 things so far. So we assumed that life satisfaction depends on some set of explanatory variables in a linear way. We assumed a reporting rule. And we assumed that it's possible that these these thresholds depend on the same explanatory variables as what life satisfaction itself, like the latent life satisfaction, depends on. If we now additionally assume that the error in this equation 1 is normally distributed, then we can estimate an ordered probit regression, where this big equation here is just the individual contribution to the log likelihood in an ordered probit model, where here this just denotes the standard normal distribution. Now, the important point is that we can't separate these betas and these deltas in an ordered probit. So instead of getting separate estimates for this one and that one, we only get their difference. But the literature always assumes that these differences are actually an estimate of beta itself, right? So when you just run an ordered probit regression of a life satisfaction variable, you make the assumption that this difference is really just an estimate of beta. So if the two have the same sign, and beta is actually larger than delta, so the effect of an explanatory variable is larger than that variable's effect on scale use, then our estimate of beta is just biased towards 0. But if beta is actually smaller than delta, then it turns actually out that, you know, our estimate of beta, so this thing that we really get, actually just has the wrong sign if we interpret it as an estimate of the actual effect on latent satisfaction of some explanatory variable. But if the effects on scale use and the effects on latent satisfaction have opposing sign, then our estimate of beta, so on latent satisfaction, is just biased away from 0. So what's the fundamental reason here? The fundamental reason is that when we observe reported satisfaction to change, we do not know whether this is because latent satisfaction has changed or whether scale use has changed. And the idea is to somehow anchor the response scale to something that we believe stays common. And in the literature, what's been proposed was to use these vignettes, which are descriptions of fictional persons that are then asked to be rated by respondents. So you might have some description where, you know, there's John. John makes so and so much income, has a wife and 2 children, but has back pains or something. And then respondents are asked, so what do you think how satisfied John is? And a couple of previous studies exist in life satisfaction research that have done that. But there's some fairly serious assumptions with that approach. So the first assumption is that respondents actually use the same scale when they assess themselves and when they assess these vignettes. Like, will they use the same standards when assessing John in the vignette as when they ask themselves how satisfied they are themselves? The second one, and I think that's the most serious one, is that respondents' perceptions of these vignettes must be uncorrelated with people's own characteristics. There's some more practical problems. So the first one is that vignettes are fairly expensive to administer because you have to give this long text and respondents have to understand it, and then they have to give some response on that. And so that just takes time and are expensive in that sense. Another important practical problem is that I don't know of any panel data set that actually has vignettes. So we can only study like interpersonal shifts in scale use, but we can't study intrapersonal shifts in scale use. And importantly, so all these studies that have used these vignettes couldn't account for individual fixed effects. So the idea that I'm pursuing in that paper is to use memories of actually changes in satisfaction to anchor response scales. And the intuition is just to compare what people remembered about the past with their actual responses. And then inconsistencies between what people remembered and what they actually reported would then either indicate scale shifts or memory biases. And so the general idea isn't particularly new. So the first study that uses this idea is by an educational psychologist called Howard, who proposed this then test, where you ask people about some subjective outcome, they give a response, you give a treatment, then you ask the respondents after the treatment what they thought what their response was prior to the treatment, and then a correlation between what they thought about the past and what they actually answered in the past. If there's some correlation between that and the treatment status, then scale shifts are thought to occur. The general thought of this DEN test has some fairly frequent applications in the medical quality of life literature. There's also two previous recent papers focusing on life satisfaction. So one is by Odermatt and Stutzer. They have it in an appendix in their recent Journal of the European Economic Association study, and a paper by Mark Fabian that I think many of us here know. So what's my contribution? My contribution is that instead of using levels, as most of the previous studies have done, I'm using memories of changes, which I think might be somewhat more sensible. Another thing is that the assumptions of the DEN test aren't entirely clear. So we don't really know under what conditions that DEN test work and under what conditions it doesn't work. And so the third contribution is that I can obtain actually a quantitative estimate of the size and significance of scale shifts, and I can adjust for coefficients of latent satisfaction using that. Okay, so in the BHPS, they asked this question about memories of changes in life satisfaction. And that question is, would you say that you are more satisfied with life, less satisfied, or feel about the same as you did a year ago? And so we can code these three response options with a -1 if this year is worse, a 0 if this year is about the same, and a 1 if this year is better than last year. Now, importantly, these responses, together with what people say this year, actually implies something about latent memories of life satisfaction. And in particular, imagine, so if we just look at this first line here, imagine that a respondent answers with a 7 today, and answers that last year was better than this year is. So this year is worse. Then what that means is that your memory of life satisfaction must have exceeded this threshold for saying a 7, right? Likewise, if you say that this year is actually better than last year, and this year I say a 7, then my memory cannot have exceeded the threshold for saying a 7. So in that sense, memories of changes contain information on the location of current cutoffs. It's not entirely intuitive, but maybe we can debate this a little further later on. Now, then we can just postulate a. Yeah, Richard?
Caspar, could we ask,
Yeah.
I mean,
Yeah.
what if the change is very small?
Yeah, okay. So that's why I formulated in precisely this way. Imagine, so let's look at this again here. So imagine a person says, this year says, I am a 7, right? And last year was better than this year. But it was just a tiny bit better. Then what this says is that, it doesn't say that, it must have, so this year I said a 7. It doesn't say that this year, then the memory must have been an 8. All that it says is that the memory cannot have been worse than a 7.
Okay, yeah, okay.
And vice versa for the case in which people say that last year was worse than this year. Okay. And so now we can postulate a model for these memories of satisfaction that is very similar in structure as the model for current satisfaction that we have. With the only difference is that we just assume that memories depend on how the past was actually like. So we just lag all explanatory variables. And we add an additional constant to allow for some general memory bias. Now the idea is that we just jointly estimate equations 1 and 2. And then what we get is just in the first line, exactly the same thing as we had earlier. So that's just an ordered probit bit. And then, because Katja asked about this, I hope I can give some intuition on these terms below here. So these terms are terms for the cases in which a person says that, you know, this year is actually worse than last year, and this is a term for this year is actually better than last year. And what we have here are just essentially, we can think of them as just binary probits that are kind of sort of attached to the model, where you know, you're just, if you didn't pass the threshold, where the chaos threshold in your memory, we're in this world, and if you did, we're in that world. So it's like a probit, but specific probits depending on which response category you answered with in your current life satisfaction. Okay, now in cases where, you know, the lagged variable and the current value of the explanatory variables are different, we can actually separately estimate the coefficients on latent satisfaction, the coefficients on latent memories, and our scale shifts. Now, importantly, these alphas, so the coefficients on latent memories and the coefficients on latent satisfaction, they don't need to be equal. So in that sense, memories can be biased. But what we do require is that latent memories cannot depend on current values of explanatory variables when controlling for past values of explanatory variables. Okay, having talked about all this modeling, I'm using the BHPS, all the waves that are available. Life satisfaction is recorded on a 1 to 7 scale. The variables I care about here, just to showcase these results, are household income, employment status, marital status, household size, childbirth, and reference income. And I include individual averages of all these explanatory variables to account for individual fixed effects. So I use these Mundlag terms. Okay, how are we on time?
Well, Caspar, if you could round up and walk us through the empirical application, your conclusion in the next 3 to 4 minutes.
Okay, so then I will skip the descriptive evidence for now, and maybe we get back to it. And so, okay, here are the main results. So in this column, I just estimate, in essence, just an ordered probit of the life satisfaction data. And in this, I estimate a model that takes account of these scale shifts by using this data on memories of changes in life satisfaction. What I observe is that when I account for these scale shifts, essentially the size of almost all explanatory variables, the magnitudes of the coefficients increases by, in some cases, by quite a margin. So especially in the case of widowhood. And that's reflected by the scale shifts always having the same sign as the effects on latent satisfaction. So for example, for household income, we have a positive coefficient on latent satisfaction, and we also have a positive effect on scale shifts. So what that means intuitively is that, you know, as people have higher incomes, the way they use their scales becomes more stringent. And one way, maybe I will skip this. So okay, so that's nice. In essence, these magnitudes of coefficients are somewhat underestimated when we don't account for scale shifts. But does this really matter? And one way of thinking about whether this matters is to think about whether ratios of coefficients that you, for example, need to get at these shadow prices when you want to price things that for which we don't really have a price, but we want to use satisfaction data, then we use ratios of coefficients, right? So the question is, does accounting for scale shifts make a difference to these ratios? And it turns out that although all of the magnitudes are underestimated, the relative magnitudes aren't too biased. So I only get for one of the employment statuses, I get a significant difference in the coefficient ratios. Now, importantly, these coefficient ratios are all estimated quite imprecisely, but I think that's a general problem when we want to do these sort of things of trying to cost things against income using satisfaction data. Okay. Then I also want to just show you the results for the memory equation. So we had this equation where we just postulated this model for past satisfaction. And it turns out that the effects of explanatory variables on these memories are fairly similar as the effects we observe on current satisfaction. So for example, unemployment both in the past makes your remembered satisfaction worse, just as current unemployment makes your current satisfaction worse. Okay,
Sorry,
so then I also have a...
Could you just clarify this business of memory? I thought the only thing that you have on memory is was it better or worse?
Yeah.
Or is there some other information on memory as well?
No, so that's all we have. So what I have is a person saying, I am a 7 today, but last year was worse, right? Now what I do is I postulate that there is something latent, a latent memory of satisfaction, just in the same way as we postulate that there's something latent current satisfaction.
I see.
And then I use that information on the changes to estimate these effects on the memories. So then I have some pardon?
Right. Sorry. I don't know if this is related to Richard's question, but it's panel data. So you actually do have the X's in the past and the response in the past too, right?
Yeah, I do. And they are used in the sense of these all being, the effects of the lags. So in that sense, the panel is being used, right? Because we assume that your memories depend on how the past was like. Then I have some extensions that let's see if we have time to talk about these, but maybe it's sensible to now just move on to the conclusions. So the first conclusion is that and I think that's a good news for happiness research in general, is that the signs of coefficients seem generally unaffected by these intrapersonal scale shifts. So that's good. The second thing is that coefficient magnitudes are generally underestimated. But I'm not sure how important that is, because although ratios of coefficients differ, these differences are rarely statistically significant. So this entire approach relies on this on the normality assumption of the errors in the model, but more importantly, I think on this assumption of present independence, that your memories cannot depend when controlling on for past covariates on values of current covariates. So the idea is, and we put in the proposal with the SERP, to make this more testable by essentially asking people about memories about multiple years in the past, and then them trying to recollect what they had said last year, just a number. And then another next step that I think is worthwhile taking is trying to connect this sort of analysis with this other concern that came out from Bond and Lang about whether people use scales in a linear way or in some other way. And I think that will be then the next steps with this general set of ideas. So yeah, thanks for listening.